Hey everybody, so we're doing lesson 3 right now. We're determining cosine and sine values from the unit circle. Because we talked about acute angles in a right triangle and we really looked at special right triangles, now we can actually define and use those with the whole unit circle. So a unit circle is a circle with radius of 1 unit. In order to identify real numbers with oriented angles, we essentially wrap the real number around the unit circle and associate it to each real number of t with the arc. So it's almost like we have the sun and we're wrapping it around. So starting 0, we go around here. For negative, we go clockwise. So what we're going to do first here is sketch the oriented angle in the unit circle corresponding to each of the following real numbers. So what we're going to do is actually, we're going to make sure that we're realizing the rotation of it also. So 3 pi over 4 is 3/8 of a rotation. So when we look at the unit circle, I don't know why I just did that. My circles are terrible, guys. I also keep in mind that 3 over 4 is 3/4 of a whole, right? Well, don't forget a circle is 2 pi. So a whole or 1 pi would be half the circle. So 3/4 of the circle is going to be between your half and your whole. So, and we remember that the angle always starts at the positive x-axis. So here is our 3 pi over 4. Now, if we look at b here, we have negative 2 pi. Remembering that the negative means we go clockwise, so we start at our positive x, and we're going, there's 1 pi, 2 pi. So that's our angle. Negative 2. Well, let's relate this back to what pi actually is. Pi corresponds to 3.14, so on and so on, right? Pi halves relates to half of that, which is 1.57, so on and so on. Negative 2, well, 2 in general is between the two, right? So, and 2 is closer, let's see, closer to, let me see, sorry. Okay, it is less than half in between those two, right? So if we're going to the left, not left, we're going clockwise, right? Half, pi over halves would be right here. Pi would be here. This is halfway in between, and we said it was going to be less than that. So let's estimate it to be that negative 2 is about here. So we're going to use the actual numbers and rotations where that angle actually ends up. Now, 117, that's crazy, right? That means it goes around and around and around. So if you think about it, we need to figure out how many 2 pi's are in 117. So 117 divided by 2 pi comes out to about 18.62. All right, so 18 is how many times we're going around and around and around and around. We get 0.6. 0.6 is more than a half. Well, a half of a rotation is pi. So a little bit more than half makes us in our third quadrant here. And remember, we went counterclockwise, so it is, because it's positive, Now I made a full circle here because you gotta imagine that it goes around and around and around. I can't make 18 of them, that would look crazy. But it actually ends up right here because that's our coterminal side. All right, cosine and sine as circular function. This leads us to our new definition for cosine and sine functions. Consider an angle, theta, in standard position and let P denoted the point where the terminal side intersects the unit circle. Which means, of course, this radius here is the value of 1. So P is where our angle intersects that unit circle. Okay. Well, in that case, we see that the x value of our coordinate relates to cosine because it's adjacent. Think about if I just brought this sine down from theta, and this is theta here, right? This x value is our adjacent side. Our adjacent side relates to cosine. And our opposite side here, which is our y, opposite relates to sine. And this explains it a little bit better down here. By associating the point with the angle theta, we are assigning a position on the unit circle to the angle theta. The x-coordinate of P is called cosine of theta, while the y-coordinate of P is called sine of theta. It is important to note that any angle that is not labeled as being in degrees is by default assumed to be radians. So remember, if it doesn't have a degree symbol there, you're automatically assuming that it's in radians. All right, so what we're going to do is find cosine and sine of these angles. The best thing to do this is really to think of your unit circle, right? So if I did a rotation for 270 degrees, well, this would be 0, right? This is where we started, 0, 90, 180, 270. So it would be right there, which we know is the coordinate 0, -1. So cosine of 270 equals 0 because it's the x-coordinate, and sine of 270 equals -1. Let's look at B, negative pi. So when we think of this rotation, start at our positive x-axis, and we're going to go negative pi, so clockwise. So we end up here. Okay, but of course we're going to deal with the unit circle, which is this point right here. Well, what's this point? This point is -1, 0. So let's write that in then. So cosine of negative pi is -1, and sine of negative pi is 0. Sorry, my pencil. Okay, 45. Let's look at this rotation. 45 degrees. There's our 45. Now, if we think of our special right triangle, right, and 45, we get the square root of 2 over 2 and the square root of 2 over 2, right? That's what we got from the last time. If you want me to go over that again, I can, remembering that this is our 45, 45. And think about our Pythagorean Theorem, knowing our hypotenuse is 1, but both of these sides, even though we have an xy, y equals x. So I can say x squared plus x squared equals 1. And when we solve this out, we get that x equals plus or minus the square root of 2 over 2. But we need to keep in mind that we went positive, x is greater, so we're going to cross out the negatives. So that's where we get our square root of 2 over 2 comma square root of 2 over 2. So cosine of 45 equals square root of 2 over 2. And sine of 45 equals square root of 2 over 2. All right, pi over 6. Let's look at that as a rotation. So pi over 6 is more than a fourth. So we've got it right here. We have our unit circle. Oh, and I went too much, right? Pi over 6. Sorry, guys. Pi over 6 ends up being over here. Okay, it's less than a fourth, remember? So this is pi over 6. So if I think of that special right triangle, right, that's our 30, 60, 90. And if you remember that your 30, 60, 90, because this would be 30, right? Your y would be 1/2, which then if you use your Pythagorean theorem, you get x equals the square root of 3 over 2. Again, it's positive because we're in the positive way. And then we have cosine of pi over 6 equals 1/2. Nope, square root of 3 over 2. Sorry, because it's x. And sine of pi over 6 equals 1/2. All right, now let's talk about 60 degrees. Well, 60 degrees is more than 45, right? So we're right up here. And if you think about that triangle, okay, well, if that is 60, again, 30, 60, 90. Radius is 1, so of course across from 30 is 1/2. Pythagorean theorem told us last time is square root of 3 over 2. So that means cosine of 60 equals 1/2, because that's the x value, and sine of 60 equals the square root of 3 over 2. Now here, we think about this as the approach that we use for our special right triangles. Those are really good to use for that first quadrant, right? That 0 through 90 degrees. But our whole unit circle goes into all the quadrants. So when you think about it, the quadrant tells us what sine, cosine or sine, is going to be. So the first quadrant, they're both positive. The second quadrant, we have cosine is negative, sine is positive. Third quadrant, they're both negative. Fourth quadrant, cosine is positive, sine is negative. We can take our special right triangles, use those, and then figure out if it's positive or negative by what quadrant they're in. So let's actually play a little bit with that now. So, Pythagorean identity. Because the point xy really corresponds with the coordinate of cosine theta, sine theta, we can expand the Pythagorean theorem into the Pythagorean identity, which uses our angles. Because think of it, our Pythagorean theorem is x squared plus y squared equals, or a squared plus b squared equals c squared, right? Or two legs, which in this case are x and y, and our c, which is our hypotenuse, right? But in this case, our hypotenuse is the radius of 1, and our x value is cosine. So I have cosine squared theta plus sine squared theta equals 1 squared. but 1 squared is just 1. So that's where we get our Pythagorean identity. So when we are using the unit circle, we can actually use the identity to help us find other values. So let's demonstrate that now. If theta is in quadrant 2 with sine theta equaling 3/5, find cosine. Again, we're using the unit circle for this. So I would get cosine squared theta plus 3/5 squared equals 1. Now when solving, cosine squared theta plus 9/25 equals 1. Cosine squared theta equals 16/25. Now take the square root. What I want you guys to keep in mind is when we have our cosine theta on this side, now it's plus or minus 4/5. Because the square root of 16 is 4, the square root of 25 is 5. But it's not both answers because we're told that it is in the second quadrant. And in the second quadrant, so Q2, cosine is negative. So this means that cosine theta equals negative 4/5. Okay, let's do this again. Now think of this. Theta is between pi and 3 pi halves. Which quadrant is that? That's quadrant 3. So let's set this up again. Get the square root of 5, well, negative square root of 5/5 squared plus sine squared equals 1. So here we have 5/25, and then we're going to subtract that. So I'm skipping just one part this time, guys. So we get sine squared theta equals 20/25. There we go. Square root both sides. Now, when we square root both sides, guys, plus or minus. But I also want you to keep in mind, we're not going to keep the square root of 20 there. You're going to simplify it down. The square root of 20 simplifies to 2 square root of 5. And then the square root of 25 is 5. If you do not know how I got the square root of 20 is 2 square root of 5, make sure you ask me later to get that down. Now we're in the third quadrant, and in Q3, sine is negative. So our final answer is that sine theta equals negative 2 square root of 5/5. All right. If sine theta equals 1, well, again, we're going to use the Pythagorean identity. So we get cosine squared theta plus 1 squared equals 1. When we end up getting cosine squared theta equals 0. Well, let's remember that 0 is neither positive nor negative, so we just keep it as cosine theta is 0, and we're done. All right, summary or symmetry. Another tool which helps immensely in determining cosines and sines of angles is the symmetry inherited in the unit circle. Suppose, for instance, we wish to know the cosine and sine of theta pi/6. So, 5 pi/6. First thing what I want to do is talk about where it lands and how we can use that relationship. Okay. 5 pi/6 is close to 6 pi/6, which is pi. So we know that 5 pi/6 is right here. And technically, if we look at this 5 pi/6, Well, really, it's pi over 6 away from that x-axis. And we can use that relationship to allow us to find 5 pi over 6. Because I can reflect it right here and use what we just did on the other page to help us solve for sine and cosine. Because you think, when we have pi over 6, our coordinate is 3 pi over 2, comma 1/2. So we can relate that with 5 pi over 6, but doing it in the second quadrant. So cosine theta, or let's do 5 pi over 6, because that way it's in your notes correctly. Even though we think of it like, okay, that would be square root of 3 over 2, because it's in relationship to pi over 6. It's in the second quadrant, and we know in the second quadrant cosine is negative. Sine 5 pi over 6, relate that to pi over 6, which is 1/2. It's in the second quadrant, and sine in the second quadrant is positive. That relationship that we're actually talking about is reference angles. So we're always referencing it to the acute angle made in that first quadrant. Okay, we're referring it back to that first quadrant, but then adapting it as in, is it positive or negative based on what quadrant it would have been in. So that allows us to make a chart, and we're going to be able to continue this. So let's start at the beginning, and I'm actually going to use another one down here because I'm going to use 90. So we have 0, 30, 45, 60, and 90. In radians, that would be 0. 30 would be pi over 6. 45 would be pi over 4. 60 degrees would be pi over 3. And 90 is pi over 2. Well, if we refer back to our special right triangles, I know that cosine, well, at 0 because it's coordinate, I guess, so not right triangles yet, but at the coordinate, cosine would be 1, sine would be 0. Let's do our pi over 2 really quickly. That would be cosine is 0 and sine is 1. So now let's go to our special right triangles, and if I bring that straight down so you can see our x and our y, right? This would be 30. So that means cosine is the square root of 3 over 2, and sine is 1/2. Just as if we do 45, oh, I put the 0 and 1. I just noticed that, guys. I'm sorry. I hope you put it in the right spot. There we go. 45 for pi over 4, we know that the sides are square root of 2 over 2. Sorry, guys. Okay, and that our 60-degree angle, or pi over 3, our x value there for our cosine would be 1/2, and our y value would be square root of 3 over 2. And that should come a lot easier the more we use it. All right, so what we're going to do now is we're going to relate it back to the reference angle to allow us to be able to get these degrees a little bit more. So 225, if you look at the reference angle, 225 is halfway between 270 and 180, which means the reference angle is 45. And then if you think about where 225 not lives, but where it ends up is in quadrant 3. Well, now we know that cosine of 225 is square root of 2 over 2. And we also know that in quadrant 3, cosine is negative. So it's going to be negative square root of 2 over 2. Whereas sine 225, well, we know it relates to the 45-degree angle, so that's square root of 2 over 2. And in quadrant 3, sine is also negative. All right, for B here, theta is 11 pi over 6. Well, first I want you guys to know that with the reference angle, it's nice because the reference angle, you can look for the denominator. So I know the reference angle is pi over 6. Now, where does 11 pi over 6 end up being in the unit circle? 11 pi over 6. 11 pi is close to 12 pi, and 12 pi over 6 would be 2 pi. So that tells me it's in the fourth quadrant. All right, so let's look at this. Cosine of 11 pi over 6 then, in relation to pi over 6, is square root of 3 over 2. And cosine in the fourth quadrant is positive. Sine 11 pi over 6 in relation to pi over 6, well, that would be 1/2, but in quadrant 4, sine is negative. All right, this one's going to be a little bit different. Reference angle is easy to compare, so it's over 4, so it relates to pi over 4. That's nice. But when we think of 5 pi over 4, I need you guys to remember that this is negative, which means we're going clockwise. Okay? So we're going clockwise. As you can see, we have 1 pi in there. Do you guys see that? Because 4 pi over 4 is 1 pi, leaving 1 pi left, or 1 pi over 4 left. So really 1 pi, and then we need to go to 1/4 right here. What quadrant is that in? That's in quadrant 2. So cosine of negative pi over 4, of course, relation to pi over 4 would be square root of 2 over 2. Cosine in quadrant 2 is negative. Sine of negative pi over 4, relation to pi over 4 is square root of 2 over 2. And in the second quadrant, sine is positive. Okay, 7 pi over 3. So reference is pi over 3, and that's great. But when you think about where it ends up, I want you guys to notice that there's a 2 pi in here, right? 3 goes into 7 twice. So it's a full rotation, leaving 1 pi over 3 left, which makes us in the first quadrant. So cosine of 7 pi over 3 in relation to pi over 3 is 1/2. Quadrant 1, cosine is 1/2. Sine of 7 pi over 3 in relation is square root of 3 over 2. First quadrant, positive also. All right, so we're going to try to summarize all these things together. Did I just lisp all these things together? So suppose alpha. So for the rest of these, alpha is going to be 5 over 13. Find sine of alpha and use this to plot alpha in a standard position. Okay, so if we know cosine alpha is 5/13, we're going to use the Pythagorean identity. So 5 over 13 squared plus sine, why did I put alpha? I'm thinking ahead. Sine of alpha squared equals 1, because we're doing standard position. When I do this math out, I end up getting sine alpha equals plus or minus 12 over 13. Okay. Now, what's very important is since we are in standard position, it means that we're dealing with the first quadrant there. Okay. So when we make our unit circle, and I draw my angle, that means that my position on that unit circle is 5/13, comma 12/13. Again, it's positive because we're in our standard position. Now what we're going to do is we're going to use our standard position to be able to calculate other angles or other thetas. So here we have theta equals pi plus alpha. Okay, so I'm going to draw it out so you guys can see it. Pi, we see here, but then we're going to add alpha onto it. Well, what does that mean? That means we're in the third quadrant. So our position stays the same, but our positive negative changes. So this means that our coordinate is negative 5/13, comma, negative 12 over 13. So cosine theta equals negative 5/13. Sine theta equals negative 12 over 13. Okay, let's try this one. This one's 2 pi minus theta. So 2 pi means that we would go full rotation, but now what we're going to do is subtract theta. So one thing I want to do is remember, not theta, alpha. Remember that we added on theta. So this angle here is theta. We subtracted theta. So I keep saying theta. We added alpha here, so this angle is alpha. We subtracted alpha, so this angle is alpha, which means we're in the fourth quadrant. So our position is 5/13, comma, negative 12/13. Cosine is positive, sine is negative. So cosine theta in this case is 5/13. Sine theta is negative 12/13. One more. 3 pi minus theta. Okay, let's draw that out and see what it looks like from here. So there's 2 pi, 3 pi, but we are subtracting, so we're going backwards. But as you can see, since we went backwards, this is alpha. We went backwards, alpha right here. So where are we? We're in the second quadrant, which means we have negative 5/13, but our sign there is positive. So officially, cosine of theta equals negative 5/13, and sine theta is 12/13. Oh, now here's the tricky part. Ready? Okay, pi halves is right here, and we're going to add on alpha. So right here, this angle right here is alpha. What's the problem? The problem is our position. our reference angle. Our position and our reference angle help us. But those come from where the angle meets the x-axis. So if you see, when we talk about what position we're at, we're actually looking at the opposite one. So in other words, connect it with the 30-degree angle and the 60-degree angle, right? Those two, what happens when you're talking about opposite there? Talking about how much away you switch your coordinates. So in this case, the position of our coordinate is going to be 12 over 13, comma, 5 over 13. Okay, just because alpha is no longer connected with the x-axis, it's connected with the y, so we have to switch those. We're still in the second quadrant, which means our sine is positive and our cosine is negative. So cosine of theta in this case is negative 12/13, and sine theta is 5/13. All right, so what is this here is lots of times when we are going back and forth, we're talking about theta and real number t. So lots of times they'll go back and forth. So they'll say cosine of t, sine of t for the coordinate, but it relates to theta. So just be careful that if they talk about units of t, they're talking about theta and what angle we're looking at it. It's just with t, they're talking about the position on the unit circle where it lays. That's the coordinate with it. And as you can see, if you turn the page, we are now done with lesson 3. You can do some practice. Make sure you ask questions if you have any.